In this lesson, we'll look at applications involving linear models. In this example, we're told that it costs $425 for a printer that prints photos, and that to print each photo, it costs 52 cents, or $0.52 for the paper and ink. And first, we'll be asked to write a linear model for the cost of printing photos. Notice that we were given two components for this cost. The 52 cents per photo is the variable cost, or the per unit cost. This 52 cents will be multiplied by the number of photos printed. So if we let x equal the number of photos to be printed, we'll have 52 cents, or $0.52 times x as part of the cost. The $425 for the printer is a one-time fixed cost that does not depend on the number of photos. So we have a fixed one-time cost and a variable per unit cost. When we write a linear model for the cost of printing photos, we'll be writing the equation of a line, and we'll use x for the number of photos to be printed and y for the cost of printing those photos. Whenever you're writing a model for an application, you should always define the variables. What do these represent in terms of the application? You could use other variables for these, like c for cost. X is pretty typical for the quantity or the number of something. But we'll use y and x, so this will look similar to the equations of lines that we've worked with so far. So let's start this equation with y, the total cost, on the left. And this cost will be equal to the $425 that we had to pay for the printer, plus 52 cents, or $0.52 for each photo, which will be $0.52 times x. Notice that this equation is in slope-intercept form, because we have y is equal to m times x plus b. The order doesn't matter. We have one x term and one constant term. So the coefficient of x, the 0.52, is the slope. And that makes sense because that's the per unit cost. That's how much the cost changes each time we increase x by 1. And the constant term, the 425, is the y-intercept because that's the fixed cost. That's the cost before we print any photos at all. So that would be the cost when x is equal to 0 in this model. This will be true anytime we're writing a linear model when we're given a fixed cost and a variable cost. You can change the order of the two terms if you prefer to make it look more like slope-intercept form, but it's not necessary as long as you distinguish between the x term, which gives you the slope, and the constant term, which gives you the y-intercept. Next, we're asked how much it will cost to print 300 photos. So we'll use our linear model with an x value equal to 300 for the number of photos. Here I've substituted an x value of 300, and now we can evaluate this expression using our calculator. This comes out to 581. And for an application, we should write this in words and include units. This says that y is equal to 581 when x is equal to 300. So it cost $581 to print 300 photos. So this is one way we can use this model. Plug in a value for x to determine the cost to print that many photos. But notice we can also plug in a value for y. That would be a dollar amount. And then we could solve for x to determine how many photos we could print for that dollar amount. Here we're asked how many photos can be printed for $1,000. To answer this, we'll plug in 1,000 for y and solve for x. This gives us a linear equation in one variable. And to solve this, we need to isolate the variable x. And we'll start by subtracting 425 from both sides of the equation. And now we'll finish isolating x by dividing both sides by this coefficient. That gives us x on one side, and on the other side, 575 divided by 0.52, which is approximately 1,106 if we round to the nearest whole unit. Since we're talking about the number of photos that can be printed, we'll round to the nearest whole number. Again, we should write this in words. This tells us that we can print approximately 1,106 photos for a cost of $1,000. Let's look at another example. In this example, we're told that it costs $325 to print 50 copies of a book and $1,050 to print 200 copies. Notice that we're given two pairs of values here. Each pair consists of a number of copies and the cost to print those copies. So we can think of this as two ordered pairs. And we're asked to write a linear model for the cost of printing copies of this book. So we're trying to find the equation of a line given two ordered pairs or 2 points on that line. So let's first identify the two ordered pairs. One pair will be 50 copies at $325, and the second pair will be 200 copies at $1,050. Since we're writing a linear model for the cost, we'll let y equal the cost in each of these pairs, and x will be the number of copies. So for the first ordered pair, we have x equal to 50 and y equal to 325. And for the second ordered pair, we have x equal to 200 and y equal to 1050. Now we'll write the equation of the line that passes through these 2 points. First, we'll need the slope, so we'll use the slope formula for two ordered pairs. And that's y2 minus y1 in the top over x2 minus x1. And now we'll simplify. And that's 725 over 150, and dividing 725 by 150 gives us approximately 4.83. Here we're rounding to the nearest penny, which is the nearest hundredth of a dollar. Remember, the slope tells us the change in y for a 1 unit change in x. So this tells us that the cost, y, changes by $4.83 for a 1 unit increase in the number of copies of books, or that each additional book costs $4.83 to print. Now to find the equation of the line, we can plug in this slope and one of the two ordered pairs into point slope form. I'm going to use the values from the first ordered pair, but you could also use the values from the second ordered pair. When we solve for y, we should end up with the same equation. So here's y minus y1 from the first ordered pair equals the slope, 4.83, times x minus x1 from the first ordered pair. Now we're going to solve for y. So first we'll distribute the slope on the right side of the equation. That's 4.83 times x minus 4.83 times 50, which is 241.5. I'm keeping this rounded to the nearest penny. Now to isolate y, we just need to add 325 to both sides. That gives us y on the left and 4.83x plus 83.50 on the right. And remember, it's good to define your variables when you're working with an application. So x is the number of copies and y is the cost to print those copies. Now we can use this model to determine the cost to print any number of copies of this book. For example, here we're asked how much it'll cost to print 500 copies. So we'll substitute a value of 500 for x in this model to determine the cost, y. So we get the equation y is equal to 4.83 times 500 plus 83.50. And we can evaluate this using our calculator. Evaluating this expression on the right gives us 2,498.50, and that's the y value when x is equal to 500. And for an application, we should write our answer in words and include units. So it costs $2,498.50 to print 500 copies. Remember that we can also use this model to plug in a value for y, which would be a cost, and determine x, the number of copies we can print for that cost. For example, here we're asked how many copies can be printed for $800. So we'll substitute a value of 800 for y and solve for x. Substituting the value of 800 for y gives us a linear equation with one variable. So we can solve this by isolating x. First, we'll subtract 83.50 from both sides. That leaves us with 716.50 on the left and 4.83x on the right. And now we can finish isolating x by dividing both sides by 4.83. 716.50 divided by 4.83 gives us this decimal that continues for several more digits, but we're talking about the number of copies of a book, and we're going to round to the nearest whole unit. So here we'll get that x is approximately 148. So to answer the question, 148 copies can be printed for $800. Let's end by taking a quick look at the graph of this equation, or this model. Here I've got a coordinate system with the x-axis for the number of copies and the y-axis for the cost. I used increments of 50 on the x-axis to accommodate all the x-coordinates in our ordered pairs, and I used increments of 250 on the y-axis to accommodate all the y-coordinates in our ordered pairs. Here are the two ordered pairs that were given in the problem. 50 copies for $325, so we have x equal 50, y equal to 325, and 200 copies for $1,050, x equal 200, y equal 1,050. And we found the equation of this line passing through these two ordered pairs. That's y is equal to 4.83x plus 83.50. So the y-intercept is 83.50. That would be the point here where the line crosses the y-axis, which may not look completely accurate here because I was drawing these by hand. And the slope, 4.83, tells us how much y changes each time we increase x by 1 unit. So for every additional copy that we print, the cost goes up by $4.83. In the second part of this problem, we were asked how much it costs to print 500 copies. So we want to start with an x value of 500 and find the y value on this line that goes with that. We found that when x was equal to 500, y is equal to 2,498.50, just below 2,500. In part C, we were asked how many copies we can print for $800. That means we want to start with a y value of 800 and determine the x value on this line that goes with that. We found that x is approximately 148 when y is equal to 800. So here on the line, when y is equal to 800, we get that x must be equal to approximately 148.